Welcome to a lesson with Dr. Powell. Let's take a look at a sequence definition, which is recursive. That means that we're given that information of how to go to the next term of the sequence depends on what a previous element of the sequence was, a sub n. Sometimes you can write a formula down like this. Maybe you have a sub n plus 1 is equal to a sub n plus 2. And then further, you know a base case, maybe at the beginning, maybe you know something like a sub 0 is equal to 3. So what does this look like? Well, you start at 3, and then to get to the next guy, so that's a sub 0, a1, let's see what that would mean. That would mean like looking at this formula and throwing in a 0 in for n. So you see an a1. So a1, because you let n be 0, and here n is 0, so you'd have a0 plus 2. So guess what? So if a0 is, okay, so we know a0 is 3, and we're just adding 2 more to get to the next guy. So we get 5. Similarly, we could calculate the rest, and we're just adding 2 each time from 1 to the next one. So 3, 5, 7, 9, 11, and so forth. So this right here is a sequence or a list. This right here, where we have a base starting case and a formula for how to go from a current item of the list to the next one. This is called a recursive definition or a recursive formula for the sequence. Now, this is a recursive formula, but you can turn this recursive formula sometimes into a regular formula. And in this particular case, notice that we have a constant slope of 2, so it looks like a linear or arithmetic sequence, and an intercept of 3 since the input value 0 right here. So the formula should be fairly simple. 2n plus 3, and you can check it. When n is 0, you get 3. When n is 1, you get 5, and so forth. And this is a non-recursive formula for this sequence, and this is a recursive formula for this sequence. And thanks for watching.